Let's now take a look at project crashing in practice. How does it work? The first thing you need to know is how much does it cost to reduce a critical path activity by a given period of time? That's a good question. And the answer is, in a real life project, you don't know. You need to analyze that as the project manager or a project team member. For practice in project management courses, typically you're given these numbers. For example, if you look at figure 9.3, you have the normal cost of getting the job done and the crash cost, how much it costs total and how many units of time it takes. And the reason that this is given is so you could calculate the slope, which is an indicator of bang for the buck. For example, in the simplified example on 9.3a, you see $25 per period reduced, whereas the example above that says $80 per unit of time. So you're trying to find activities that cost the least for the maximum unit of reduced time, or units of reduced time. That's the optimization activity. Now, there's a lot of assumptions in there. You're assuming it will actually work. You're really ignoring the risk. You're looking at only one parameter to optimize, but that's the principle. And yes, there are other things, there are other factors you could consider for optimization, but we're keeping it simple for now. So, in real life, a project manager and a team would look at all critical path activities and come to some conclusions about what could be reduced, how much is it going to cost, and then proceed to reduce those durations one by spending more money. And you're going to get direct and indirect cost, and you're going to find the sweet spot. What is the least direct cost, indirect cost combination that reduces the overall schedule? Okay, figure 9.3 provides an example where to start, starting on activity A. Okay, notice activity A goes from 3 to 2, and you see an X by there. Why is that? Because you see in the table the maximum crash time is 1. So you could reduce it by 1 unit of time, and you've added some additional cost. You've added $20 more to the direct cost. Okay, and you do this one by one, taking a look at every critical path, and as you start reducing activities, the critical path will shift, and sometimes you'll have more than one critical path, meaning you may have to reduce more than one activity to cause the overall project to reduce. As a rule of thumb, you should never spend money trying to reduce an activity that doesn't reduce the overall project duration. So that means you must only reduce durations, spend money to reduce durations of activities that are on the critical path. And as mentioned previously, as more and more activities are reduced, the critical path begins to shift all over the place. And at the end of the day, you may have multiple critical paths, meaning you may reach a point where multiple activities must incur additional funding to be reduced in order to bring down the overall schedule. So this cycles through multiple iterations in this example. And you could see, for example, in time 22, there's 3 activities that need to be reduced. And then once this is undertaken, you finally arrive at a table. Notice the combination of direct and indirect cost steadily decreases, and then it begins to increase again. So where it dips is the optimum direct and indirect cost. Okay, so it's important to never lose track of what's being done here. Remember, what is being attempted is to spend more money on critical path activities to reduce the project duration. And there's a lot of assumptions that come with this, not all of them that hold true, but if you ever have to attempt to reduce the overall project schedule, remember these rules of thumb. Do the most you can with the least amount of money. Make sure you're focused only on critical path activities because that's the only ones that play a role in reducing the overall schedule. And also think of other ways you might approach this, because once you're finished, you may have multiple project critical paths, extra resources you've thrown in the project. You're really talking about a very much more risky project than it was in the beginning, which is why I think calling this crashing is probably a good idea.